Hey girls, this is today's lesson, lesson 14 for June 4th. And those figures there should look familiar to you because we talked about that yesterday. We talked about how to classify different types of triangles. We're going to expand on that today by constructing different types of triangles. I can define and construct triangles from given criteria. So in a moment, we're going to go over those definitions of our different classifications. I can explore symmetry in triangles. We talked about symmetry on Tuesday. And also actually Wednesday on our Zoom call. So moving on to review our definitions. Here I have an acute triangle. All three angles are small. They are less than 90 degrees. Okay? Kind of like they're being maybe about here, maybe about here, maybe about here. Definitely not here because that's right. No, it's smaller than. Then we go to a right triangle. A right triangle has one right angle. We know that a right angle is exactly 90 degrees, and oftentimes we see that square to let us know that that represents a right triangle. And the last is our obtuse triangle. And it has one obtuse angle right here. And again, with obtuse, can't get it in here. Okay. Let's say that's a right angle. And then it gets wider for obtuse. So we're going to move to the whiteboard and we're actually going to use your problem set and do those examples together. All right, so we are not going to the whiteboard. I decided that we will use the grid paper in your packet to do our examples for the problem set. So the first example on your problem set is to draw a right isosceles triangle. Well, it's easy to find a right triangle on our grid because we have each square has a right triangle. So the first thing I'm just going to do is I'm just going to use the square to draw a right triangle. I want you to do the same. But now isosceles means that two sides have to be equal. So what I'm going to do is I'm going to make this side 4 squares wide, and I'm going to make this side 4 squares wide. So those two sides are equal. And I know that when I do my last side, that is definitely longer. So there is my first example, my right isosceles triangle. A right angle with two sides that are the same length. Now, what I want you to do is, just so we know, I want you to put that square representing that you know that that is a right triangle. And I also want you to put the line here and the line here to show that you know that those two sides are the same. So now your next example is obtuse scalene. And we know an obtuse angle is a wide angle. a scalene triangle has three different sides. So the first thing I'm going to do is just make a small obtuse angle. I'm just going to go right through that diagonal, right like there. So there's my small obtuse triangle. And I'm going to make this one be 2 square lengths long. I'm going to make this side be 1, 2, 3 diagonals long. And then I'm going to make my last side. Ooh, wow. Which is definitely different. Right? If I were to try to measure it, okay, this 3 diagonals, this is almost, let's say 1, 2, 3, 4, probably about 4 or 5. So showing that this is a scalene triangle, I'm going to put a line here. I'm going to put 2 lines here because this is clearly a different length. And then I'm going to put 3 lines here. So I see my obtuse angle. And I'm going to show my obtuse angle. And I also am showing that it is scalene because each side is a different length. So we're going to do letter D first, and then I'm going to go to the whiteboard to do letter C, the acute scalene. So for letter D, it's acute isosceles. So that means every angle has to be acute. 2 sides have to be equal. So this is what I'm going to do for this one. I'm going to do the base of the triangle first, which is the bottom. And I'm going to make it an even length. So and I'm going to go down probably, let's say 1, 2, 3, 4, 5, 6, I'm gonna go 7. What the heck? 7, and then I'm just going to go 4 squares in length. Now, right in the middle is where I'm going to take this up and now do my 2 other lines. Connect here and then connect here. So I know because I started right in the middle and went up that much space, I can tell that this is an isosceles acute triangle. Here's my 3 acute angles, 1, 2, and 3. And then these 2 sides are equal, 1, and this side is shorter. Now, you should notice something else about this triangle, which we didn't talk about with our isosceles right triangle, but you should be able to recognize it too, is that this triangle has a line of symmetry right down the middle. That's the only line of symmetry it has because 2 of the sides are equal. I can't go across, right? I can't go this way. It's not going to work. Right? I have my 1 line of symmetry straight down. Now, like I said, the last example we are going to do on the whiteboard board, and I'm going to be using my protractor to help me. All right, so for letter C, I want to use my whiteboard board because it's a little tricky for an acute scalene triangle. So the first thing I'm going to do I'm using my straight edge that has a measurement so I can tell how long it is. And I'm going to make a segment that is 2 inches long. Okay, 2 inches long. Now I'm going to go to the other side. And I'm going to do a segment that is a little more than 2 inches long. Okay, so I made it about 2 1/4 inches. Now, when I go to do my last one, now it's just a little bit longer than 2 1/4. It's actually a little bit longer than 2 1/2, this last one. Okay, and I can see that there. So I'm going to just measure again. Okay, that's 2 inches. Okay. This one here is 2 1/4. Yep, perfect. And this one here is 2 1/2. Okay. So they're very close together. Because I have 3 different lengths, my angles are all going to be different, even though they might look similar. So I'm just going to check the measurement of the angles. So here, there's my vertex lined up at the 0. Okay. This angle here is about 62. Okay. Now move this. This angle on this side is about 50. And then, believe it or not, this angle here, this top one, is 70. So I've got my scalene triangle with 3 acute angles. Now, what you're going to notice about the symmetry of the triangles is that if it is an isosceles or an equilateral triangle, okay, an isosceles or an equilateral, it'll have a line of symmetry. But in a scalene triangle, because all of the sides are different, there will not be a line of symmetry because none of the sides are the same, which means that none of the angles are the same. Remember, in an equilateral triangle, 3 sides are the same length, which means the 3 angles are the same length. In an isosceles triangle, 2 sides are the same length, which means 2 of the angles are the same measure. So you can get a line of symmetry. So we are done for today. Please take a picture and send it to me. Enjoy the rest of your afternoon.